Okay, hello student. So today we are going to start our next lecture, that is optics, right? Okay. So in the last lecture what we have completed, in the last lecture we have just completed about the electromagnetic wave, right? So what is the optics? In general, I hope you all know optics from the previous classes. I mean, in class 10 there is a little bit discussion about this, right? So let's see what we will cover in this segment. It's a basic intro lecture, right? So we will cover the light and reflection of light. We will cover the light means basically we will cover the reflection of light. It's all about the properties of light in this chapter, right? So let's see. First we need to understand about the optics, like what is optics and why we are studying this segment, right? Actually, what's the first thing of this chapter? We have to study about the light, right? If we have to study about the light, then there is a specific branch in physics that is called optics. Okay, so optics deals with the, we can say, effect of light, properties of light, a lot of things, everything is related to light. If we are studying, that is the branch of optics, right? Like you can observe in this, what is the optics? Optics is the branch of physics which is related to the nature of light, properties, effect and vision, right? Properties, effect and vision. Simply what we can say in one line, it's a study of, this one is the study of light. We can simply say this is what? A study of light. Okay. So a study of light is further divided into two parts. Like let's see here. What is the first one? The first one is a ray optics and the next one is a physical optics. Ray optics and what? Physical optics, right? What is the meaning of ray optics? Ray optics is also called geometrical optics. This is also called geometrical optics, right? This is also called geometrical optics. Why we are saying geometrical optics? Because basically we will use little bit geometry in this one in general, right? So what is the ray optics? Ray optics is the study of light, assuming rectilinear propagation, right? Rectilinear propagation. I hope you know about the meaning of rectilinear propagation. Like we have done in the kinematics, there is a topic that is we can say rectilinear motion. So rectilinear propagation means simply we can see straight line motion, right? And when we are seeing the light travel in a straight line, there is a certain things that we have to keep in mind. That is called the wavelength of the light should be much smaller than the size of the obstacle. The wavelength of light is much smaller than the size of the obstacle. If the size of obstacle is not large, then we cannot consider those things into the ray optics, right? There is a one term is also that is called b square by l lambda. B is what? Size of the obstacle. L is the what? Separation between the, we can say, source and the observer, and what is the lambda? Wavelength of the light. So there is a condition that b square by l lambda should be greater than 1, right? We don't have to go there, but we will discuss about that one in the wave optics. But right now what we have to remember, what is the ray optics or geometrical optics is here? Wavelength of light much smaller than the size of, right, obstacle. So what we have to cover in this one? In this one we have to cover the, like we can say, the basic properties of light, reflection. We will cover the reflection of light. Okay. Next we will cover the refraction, and we can say the next we will cover something about the dispersion, right? Dispersion of light. Okay. We will cover all these things in this. There will be some more things, scattering, we will discuss about this one. But basically scattering in detail we will discuss about this scattering in wave optics, right? So let's see here. If we are dealing with the ray optics and we are saying the size of obstacle is very small, then we will see it's a ray optics, or we can say the branch of physics in which we are studying about the light assuming the rectilinear propagation is called ray optics, right? Now let's come on the next. The next we have that is called physical optics, right? So in physical optics we will divide into two parts. What are the parts over here? The first part is wave optics. What is the first part? Wave optics. And what is the next part? That is called quantum optics, right? So in wave optics it's a normal, I hope you understand. The wave means what? We will assume the wave nature of light, right? We will assume the wave nature of light, like the light shows the dual nature, wave nature and particle nature. So this one is the branch in which we will study assuming the light is a wave, and in which we will study about the light, we can say assuming particle, right? Assuming particle. This is the study of particle nature. In wave nature, basically in our class 12th, what we have to take in this one? In our class 12th, we have to take, like we can say, the interference, right? Interference, diffraction, and polarization, right? Polarization. Okay, we have to discuss about these things in this wave nature. And what we have to discuss in quantum optics, there is a two type of things that we will discuss. The first one is that is called photoelectric effect, and there is another effect that is called Compton effect, right? Compton effect. Basically, we have to study very less about the Compton effect, but we will discuss about the more, that is photoelectric effect, and we will discuss about these things in modern physics, right? In modern physics, right? Okay. So let's see here. These are the basic intro, like how we will cover the study of light. We will divide it into this part, and we will cover one by one to all, right? So first we will go through the ray optics, right? Okay. So I said we understand the meaning of optics, like what is optics and what we are doing in this one, right? But first thing, what is the measure? That is called light. So first we need to understand what is the meaning of light and why we are studying about the light. Okay. So let's see what is the light and why we are studying about this. In general, what we are saying? In general, we are saying the light is a form of energy, right? If I will ask you what is the sound, then you will repeat the same thing. Sound is a form of energy. I can ask you anything, you will say it's a form of energy, right? So first thing, why we are saying the light is a form of energy? What is the energy? In general, how we define the energy? Energy is basically, we can say, it's a capacity of doing work, right? Or we can say the ability to do work is called energy. Okay. So in this one, if we are saying there is a light, so if we are doing the work with the help of anything, that will act as an energy for us. That will act as an energy for us, right? Like if I am saying we are just taking the light, so we are doing the work with the help of light or not? Yeah, of course we are doing the work. Like we can say the first work is we are observing to each other, right? What is the next work? There is a photoelectric effect. There is a lot of use of radiation, right? So we are just using the, or we can say we are doing the more work with the help of light. That's why we can say light is a form of energy, right? And what type of form of energy of light is? It's basically the form of energy. It's the only form of energy with the help of which we can see the any object, right? Like if I am saying there is a just turn off the light and I am just only speaking, so it's not possible that you will just observe all the things by only sound wave, right? So we only the wave with the only the energy with the help of which we are just seeing the any object, that is called light, right? Let's see here. In general, if we are discussing about the light, so we have learned in the previous classes what we have learned about the light. Like we know the light is an electromagnetic wave. What is the light? Light is an electromagnetic wave, right? Light is an electromagnetic wave. If light is an electromagnetic wave, so there is a one term that is called electromagnetic spectrum. I hope you know about the spectrum. So there is a one term that is called electromagnetic spectrum. So light is a part of electromagnetic spectrum. You can see this is the electromagnetic spectrum we have. So if I am saying in this one, this is the gamma ray we have, right? This is the X-ray, ultraviolet, visible, infrared, microwave, and this one is what? Radio. Actually the radio is also microwave. But what is happening in this one, microwave? The radio wave is basically microwave of very high wavelength. No? That is called radio wave. So let's see in this one. When we are moving from this side to this side, I mean, if I am saying we are moving from this side to this side, then wavelength is decreases. What is the wavelength? Decreases. And the frequency is increases. Wavelength is decreases and frequency is increases. There is a one thing is also that is called cosmic, right? So we are not moving on that, but we have to stick with this one. Gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio. This visible is basically light. This part of spectrum, I mean this part of radiation, electromagnetic radiation is called light. Okay, this one is light. And if this one is light, then we can say, you know about light, there is a wavelength. it's in reverse order, V I B G Y O R. This is Vigor we have. So you know very well the wavelength of light is very high as compared to the violet, right? So this is the part of electromagnetic spectrum. Okay. So let's see what is the general wavelength range for this one. This is the general length I have just written over here. No? It's a 4000 angstrom to 7000 angstrom. But in general, you can just observe there are written something else like we can say there is 3600 angstrom to 7800 angstrom. It is different in different way. But this is the standard that you have to remember, no? Right? 4000 angstrom to 7000 angstrom. And this range is visible to human eye. Only human eye can just sense about this one, right? Now let's see the next. The next we have to discuss about the properties of light. What we have to discuss? We have to discuss about properties of light. We will take one by one. What is the first one? Light travel in a straight line. It's a rectilinear propagation we are doing, right? So we know the light travel in a straight line. If light travel in a straight line, so why the light travel in a straight line? Due to its high frequency and low wavelength. The frequency of light is very high, right? That's why we are saying the light travel in a straight line. Okay. Now let's move on the next. What is the next we have? The next is a direction of propagation. It means direction of, we have already discussed these things in electromagnetic wave, right? But let's see here. Direction of electromagnetic wave, or we can say the direction of light. So how the direction of light will be? Direction is along E cross B. You know how we have to use the E cross B. It's a basically, we can say this is the right hand. This is a right hand thumb rule, right? This is what? Right hand thumb rule. With the help of right hand thumb rule, we can just find out the direction of this one. Like you can just see over here. This is the electric field is here, and this is magnetic field is here. So due to the electric field and magnetic field, there is a wave we have that is called electromagnetic wave, and in this one we are saying it's a light. So this is, if I am saying this is the vacuum we have, so this is moving with 3 into 10 to the power 8 meter per second. And light means what? Basically this is the speed of energy. This is the speed of energy, right? Let's see here the next thing. In general, what we are seeing? In general, we are seeing the light can travel in vacuum, right? How the light can travel in vacuum? Light can travel in vacuum means due to this one only, because we know they are interchangeable, electric and magnetic, right? So they are interchanging, and due to that they are producing the wave over here, right? So there is no need of any other medium. That's why we are saying in general the light is traveling in a straight line, or we can say vacuum also, right? So let's see here the next thing. If I am just taking some illustration on this one, so let's see the illustration on this one. If I am saying the direction of electric field is along positive x-axis and the magnetic field is along negative y-axis. So what we can comment on electromagnetic wave, I mean direction of electromagnetic wave. Can we find it out? Let's see here. Here what is happening? E cross B. So E is in upward direction, right hand. E is in upward direction, this is right hand, and B is outward. So how we will take the cross? E, where is the B? Outward. So we cannot curl like this. So this is E and B is outward. So E cross B. This is the direction of electromagnetic wave, right? In this one, E is along positive x-axis. If you want to draw the axis over here, you can draw. Like this is a positive x-axis we have. And you know this is a positive y-axis. And this is negative y-axis. And we are saying the Z is perpendicular to this one. Perpendicularly outward and perpendicularly inward, right? E cross B. Just put your fingers towards E. So E is along what? Positive x-axis. So this is the E we have, and this is the direction of B we have. So how we have to do it? Let's see. We have to put our finger towards E. So this is the direction of E we have, right? And where is the B? B is in downward direction. So we have to take a curl on downward, right? So E cross B. This is downward. So this is moving in inward. So we will say the electromagnetic wave is in inward direction, right? So you can just take some type of more illustration by yourself, right? Now let's move on the next. Now the next that what we have to discuss, that is the speed of light. So what is the speed of light? A speed of light is uniform in homogeneous medium. What is the meaning of homogeneous medium? I hope you understand, right? Homogeneous medium means we can say the density is uniform, optical density is uniform, right? We can say the optical density of medium of the medium is uniform, right? Medium is uniform. So let's see. Speed of light. If I am saying this is the medium we have, if this medium is the, we can say medium 1 is here, and this is medium 2 is here, right? If speed of light in this one is v1 and in this one is, we are saying v2, if m1 is equals to m2, so the v1 is equals to what? v2. The speed of light will be same if the medium is same, right? Now let's see here. Speed of light in vacuum, we all know about this one. What is the speed of light in vacuum? It is represented by c, and we know, so c is equals to what? The c is equals to 3 into 10 to the power 8 meter per second. This is the speed of light in vacuum, right? And in general, we have completed the electro and magnetism both. So what we can say over here, c is equals to 1 upon root over epsilon naught and mu naught. This is how we are getting the value of c, right? I hope you know about epsilon naught and mu naught very well. What is the epsilon naught is here? Epsilon naught is the permittivity of the free space, or we can say vacuum. And what is the mu naught is here? It's the permeability. It's the permeability of free space, or we can say vacuum, right? Or air, you can take also air, because the refractive index of air is also very small. So we can say the epsilon naught and mu naught is here. Now if we have to write the by same way, if we have to write the speed of light in medium, so what we will say about the speed of light in medium? The speed of light in medium is equals to the 1 upon root over epsilon into mu. What is the meaning of epsilon into mu? Epsilon is the permittivity, or we can say absolute permittivity of the medium, and mu is what? Absolute permeability of the medium. So we know one thing, the epsilon is equals to what? Epsilon naught into epsilon r, and the mu is equals to what? Mu naught into mu r. I hope you understand this one from the magnetism and electrostatics, right? So what we will write over here, we will write v of the medium is equals to 1 upon, can we replace these things? So we can just write it like, this is a epsilon naught into epsilon r into, this is mu naught into mu r, right? So what we will see over here, this is a 1 upon, can we just write it like this? Epsilon naught into mu naught into, this is root over epsilon r into mu r. Can we write it like this? Okay. So what will happen over here? So what is the medium is here? The medium is, this is what? This is c. So this is c by root over epsilon r into mu r. This is the speed of light in any medium for light. And you know from the previous classes, like we know the n is equals to c by v. What is the n is here? N is the refractive index, if you have remembered. This one is what? Refractive index. You have learned in class 10th, right? So this term you can just compare the term, then you will observe this term is what? Refractive index of the medium. This term is what? This one is refractive index of the medium. This is refractive index of the medium, right? Now let's see. So these are the basic properties of light. We will study the properties of light also. There is a lot of property like reflection, refraction, interference, diffraction. This is all related to the property of light. Okay. Now let's see. And one thing also I want to tell you. I said it's an electromagnetic wave, right? If this is the electromagnetic wave over here, then which one is responsible for the intensity of light? That is the electric field, right? Vibration of electric field is related to the intensity of light. Okay. Now let's move on the next thing. The next is ray, right? So before coming on ray, I think they have left one property. So let's see the one property is also here. If we are just dealing with the light, so there is a one property, that is we can say the color, right? The color of light is the property related to its frequency. Property related to its frequency. It's a property of frequency. It's not a property of wavelength. Like what we are understanding. In general, there is a misunderstanding what we are saying. The wavelength of red color is this, wavelength of violet is this, wavelength of blue is this, right? This is the range. but that is only for the vacuum, right? But when we are moving in any medium, then it will become change, right? It will become change. So, but color not becomes change. Color remains same. When the color remains same, it means the color is a property of light that is associated with the frequency. Associated with the frequency. So, on changing the medium, the frequency will remain constant. And one thing is also the frequency depends upon source. Frequency depends upon source, right? Frequency depends upon source. It depends upon source. It does not depend upon anything like medium, velocity, all those things, right? It is only the source dependent quantity. Okay. Now let's move on the next. The next we have to know some basic terms related to optics. Like there is a one term that is called ray. So we all know about the ray. What is the ray is here? Ray is simply, we can say it's a path of light. Ray is what? Ray is a path of light. This is the path of light. So path of light is called ray. Okay, that is written over here. If I am saying the medium is uniform, right? If the medium is uniform, then it will be straight line, and the ray will be straight line, right? If I am saying if medium is non-uniform, then it is maybe in curved, right? Maybe in curved means what? Like if I am saying this is the medium we have, on moving downward the refractive index is, we can say, increasing, right? So it's not possible that it will be always in a straight line. If you will just take the graph of this one, like the light is entered on this way, right? If the light is entered on this one, it has to travel on this part, but the refractive index is increases, so it will be continuously moving on this track, right? So we can see, we will see a curve over here, right? Just copy all these things, then we will move on the next property, right? Okay, so let's see the next one, right? So next what we have to do? Next we have to know about the next one, that is called beam, right? Light beam. What is the meaning of beam? Beam is basically a group of rays. This is what we can say, this is a group of rays. Either what we can say, it's a bundle of rays, no? That is called beam. So what type of beam that we have to do? The first one is, you can just observe over here. This is called the parallel beam, right? What is the meaning of parallel beam? When we are saying the parallel beam, when the cross-sectional area of the beam remains constant, you can see the cross-sectional area of the beam for each and every point will remain same. I hope you understand the meaning of cross-sectional, right? Like when you will observe from this side, when you will observe from this side, then you will see there is a beam over here, right? This is the area of this beam is called cross-sectional area. Cross-sectional area, right? So in this one, the cross-sectional area will remain constant. Either you can also say, if area will remain constant, so there is a term like, we can say the radius, diameter, all the things will remain constant, right? Now let's see the next one. The next one is called convergent. Convergent means what? You can observe that converging at a single point. In this one, what is happening? Can we see the area is decreases? In this one, the area is decreases. Either what we can see, the diameter of this cross section is decreases, right? And the next one is divergent. Divergent. In the case of divergent, we can say the diameter is increases, or we can say the area is increases. This is called divergent. Actually, this one is very important for us. Why this one is very important for us? Because what we are observing, we are observing due to the divergent, right? If we are observing any object, then there is a divergent light is coming to us. Then we can observe that one. We cannot observe the convergent, right? If I am saying, let's assume there is a human eye, right? Let's assume this is the human eye we have. If this one is the human eye we have, and we are seeing, we are just incident a light from this, and this light is we can say the light is convergent over here. So can you see about what do you see over here? You cannot see anything, right? It's a practical thing. You can just incident the light on your eye, then you will not absorb the object if it's a convergent, right? Human eye will only detect the divergent ray, right? There is another method like for convergent we will do it divergent and then we will observe. We can do such type of things, but in general what we are observing divergent. Like if I'm saying, let's see, this is the object we have, no? Right? This is the ball we have, and we are saying you are just standing over here, right? If you are just standing over here and you have to observe this one, so how you will observe? When the light is coming to this, no? Right? So you can just observe this is the divergent, it's not convergent, right? Okay. Now let's move on to the next thing. The next thing that what we have to discuss is sources. Sources means what? Simply in light you can say object. Like what we are observing. Source means like how we are getting the light. Like right now if I am observing the camera, so I am just getting the light from the camera. So I can say the camera is a source, either we can say camera is the object, right? So we can say in light source or object. So source or object there are two types. One is called the luminous and another is called non-luminous, right? What is the meaning of luminous? The luminous means emits their own light, right? And what is the meaning of non-luminous? Reflect the light falling on it. That is called non-luminous. So when we are saying about the emits their own light, so you know, like there is a sun, electric bulb, a lot of things are there that are called luminous. And what is the non-luminous? Like everything what we are observing in general is non-luminous. Like if I am saying you are observing to me, so I am a non-luminous to you, right? I am not just reflecting any light. There is a light incident on me, so that's what I am just reflecting. I am not radiating the light, okay? I am radiating the energy, but that is not in visible region, right? You know about there is a concept in thermodynamics, right? That is called Prevost theory, right? I will come on that in thermodynamics. Let's see. The next is what? Optical medium. What is the meaning of optical medium? It's a simple term, that is in which the light rays travel. I am just taking this basic term because if you have forget from the class 10, then you will recall all these things. What is the optical medium? In which the light ray can travel. That is called optical medium. So there are two types of optical medium. What is the first one? Rarer. And what is the second one? Denser. Right? Rarer and denser. So if this is the rarer and denser over here, then this is relative term. It's not absolute. Like we cannot say this medium is absolute rarer, this medium is absolute denser. We cannot say such type of terms, right? If I'm saying we are just taking the glass and water, right? So what is happening in glass and water? In the case of glass and water, if we are comparing on the basis of optical density, so we will say the glass and water, right? Glass and water. So glass will be denser as compared to water. So water will be rarer for that, right? Water will be rarer. You can take another, like I said, we can take the water plus air. In this one what will happen? The water is denser and air is what? Rarer, right? Air is what? Rarer we have, right? Okay. Now let's move on to the next. The next thing, we have to move on the properties of light, right? So let's see what is the properties of light. It is the first property that we have to discuss. That is called reflection of light, right? Reflection of light. We have learned all the basics things in the previous classes also. Now we are in 12th, so I hope you understand this one, right? What is the meaning of reflection of light? When we are saying reflection of light, so first thing comes like what is the meaning of reflection? Reflection means if there is anything which incident on the any object or anything and reflect back in the same medium, like when I am just throwing a ball on the wall, right? So ball is returning in the same medium, no? It's not like the ball is penetrating the wall. If ball will penetrate the wall, then we can say this is refraction because the ball has changed the medium. If ball is not changing the medium, it is coming into the same medium, then we will say that is called reflection, right? Like if I am saying there is a bullet, right? So let's see, this is a wall we have. Either you can say this is a glass we have. If we are just firing a bullet on this one, then what will happen? A bullet is incident on this one and it will penetrate up to some distance, right? So this is not a reflection, this is a refraction. Why this is refraction? Because we are assuming this is air and in this one there is a medium, right? And this is a medium of what? Glass. So this system is changing the medium, then that is called refraction. But when it will reflect back, then we can say this is called reflection over here, right? So let's see what is the meaning of reflection of light. The reflection of light means it's a bouncing back of light from any surface. Either the light is completely bounced, either the some part of the light is bouncing, like you can see partially or wholly. This is called the reflection of light. So let's see here. There is a surface we have, right? This is called reflecting surface. This is what? This is called reflecting surface we have, right? This is the reflecting surface, and you know previously, like this is what? This is incident ray, and what is this one? This one is reflected ray. This one is reflected ray, and this one is called normal, right? And this is what? This is called incident point. This is called incident point, right? And I and R, you know about I and R. I is the incident angle and R is what? Refracted angle. Now let's see here. We have to move on the next thing, that is called the laws of reflection. So what is the meaning of laws of reflection? In this one you can just observe, this is the plane we have. Light is incident and returned back into the same medium. It is not entering in this one, right? So this one we can say this is called reflection of light. So in this one, there are some laws like how the reflection takes place from any surface. So what are the laws over here? The first one is what? The first law of reflection is, we all know. What is that one? The incident ray, right? We know the incident ray normal at incident point, normal at incident point, and reflected ray are lies in same plane, right? These are lies in same plane. So I have just drawn the plane over here. This is incident ray and this is reflected ray. So you can just observe over here. This is normal. Then this is the plane over here in which all the three are lies, right? This is the plane over here. So in this plane all the three are lies. It's not look like that. If I am saying this is the plane we have, right? A light is incident over here. So this is the incident, this is the normal, and it will be reflected. It's not like it is reflecting over here, reflecting over here. All the three should be in the same plane. That is what the first law of reflection, right? Now let's see what is the second law of reflection. The second law of reflection is, we can say angle I is equals to angle R. And this is valid everywhere. No? Like you know, there is a types of reflection that is called regular reflection, irregular reflection. So it's a valid for all. Angle I is equals to angle R, right? Now let's come on the next thing. We have to just remember some points. Let's see. If I'm saying there is a surface we have, I'm just drawing over here. This is the surface we have, right? If this is the surface we have and the light is incident on this one, this is the light is incident over here. And we are saying this surface is dividing two medium. This is the medium 1 we have and this is the medium 2 we have, right? So when light is incident on this one, so we are assuming there is a velocity v, wavelength lambda, intensity I, and frequency is f over here, right? And you know there is a normal v here. And if we are saying there is a reflection, so it will reflect back in this one. For this one, the velocity is v dash, wavelength is lambda dash, intensity is I dash, and the frequency is f dash over here, right? Now what we can see about this one, if I am saying there is a reflection takes place, then what are the changes in all these things, right? So let's see here. Velocity. Can we say light enters in this medium? I mean from this medium and reflected in the same medium. So what I said initially, if the medium is same, then speed of light will remain same. So we can say from this one, the v is equals to v dash. Velocity will remain same, right? Now let's come on the next thing. That is called frequency, right? Frequency. I initially said the frequency depends upon source. So frequency will also remain same, right? So what is changing over here? Lambda or I? Now let's come on the lambda. We know the light is also shows the wave nature, right? So if light shows the wave nature, so it follows the V is equals to F lambda. You know from the class 9th, V equals to what? F lambda. So V is what? Velocity, F is what? Frequency, and lambda is what? Wavelength. If I am saying in this one, you can just observe over here, V, F are same, so lambda should be same. How it is possible that lambda can be different, right? So can we say V and F is same, then lambda will remain same? It means the lambda is equals to lambda dash. Lambda is equals to what? Lambda dash. Now let's see the next one. The next is intensity. Next is what? Intensity. So in reality, the intensity changes. After the reflection, what is changes? After the reflection, the intensity changes. I dash is less than I. Or in general, what we can say, the intensity is decreases. Intensity is decreases. And one thing is also, we are discussing about only reflection. We are not discussing about total internal reflection. That is an entirely different thing, no? Right? It's an entirely different phenomena. In this one, intensity is decreases. If I'm saying, let's assume there is a sunlight outside your home, right? And you have taken a mirror and you are reflecting the light from your mirror to your home, right? So what will happen in that situation? The intensity of light at the mirror is not same at the intensity of light at where we are just projected that one, no? Because there is not a complete reflection. There is not a complete reflection. What I have written over here, partially or wholly. So in general, there is a partially reflection. It's not like there is a 100% reflection we are taking over here, right? Now let's see here the next. So in this one, what we have to remember? We have to remember the intensity of light is decreases. This one is important, right? So after reflection, in general, the intensity of light is decreases. Okay. Now let's see the next thing. The one thing also that we need to understand. If I am saying we are observing, like I am saying, right now you are observing to me, right? So what is happening? There is a light is just radiating from your LED, right? I mean monitor or display, whatever. So you are observing to me, right? You are also observing the other thing, like you are observing your pen, your copies. Then what is happening on that? The light is incident on them, and you are observing. And there is also, it may be sure there is a water, right? If there is a water, then we are also observing the water. Then what is happening over here? I am saying this is your book we have, right? If this is your book we have, then I said you are also observing your book. Okay. So this is our book we have, right? We are observing the book. So there is a light is incident on this one and you are observing. And I said there is also, let's assume there is a water. If there is a water, then this is the water we have, right? If this is the water, then what is happening in this one? The light is incident on this one and it reflect. Also it goes under the refraction, there is not an issue. Some part will goes under the refraction and some part is goes under the reflection. That's why it's visible that water surface is visible to us. If 100% refraction will be there, then it's not possible that we can observe the water surface. How we are observing the object? Due to reflection. Actually there is a two concept to observe the system, right? The first one is we can say reflection and another is radiation. Reflection and radiation. How we are observing from the reflection and radiation? Like I said, there in this room, let's assume in this room, we have just turned off all the light. If we have just turned off all the light, then what will happen? If you will turn off all the light, then we can say nothing is visible over here. I will also just turn off this one. But if I will just take a hot iron bar, if I will take hot iron bar, then what will happen? Can we say this is visible? Why? Because this one is radiating the light. If I am saying this is a hot iron bar, if this is hot iron bar, then it is radiating the light. And actually it is radiating the light in different wavelength, but it is also radiating the light in visible region. That's why we can say it is visible to us. So if we are just observing any object, for observation of any object, we have two things. What are this? The first one is reflection. And what is the next one? Next one is radiation. Next one is what? Radiation. And you know one thing, like if we are just observing the color, so what is the meaning of color? Like if I am saying this is the look like green to you, So what is the meaning of this one? If this is look like green to you, it means if the light is incident on this one, right? So it absorbs the others and it is reflecting the green. It is reflecting the green. If we are incident, the viewer over here, so only green is reflecting over here. The others it is absorbing, right? If I am saying we are just taking, this is the object we have, right? And I said this is, we can say it's yellow, right? This is yellow, and we are incident a light over here. We are not incident yellow on this. Then what will happen? It will absorb all the light, and the temperature of this one is increases, right? If the temperature of this one is increases, so with respect to time, if this one is observing, then temperature is increases. And there is also one thing: if it is also placed in surrounding, if temperature of surrounding is small, then what will happen? It is also just radiating some light, but it is not radiating in the form of visible, in the range of visible light. So that's why these are not visible to us, but it is also radiating. If it is not radiating properly, I mean the incident energy is more as compared to the radiating energy, then sure the temperature of this one is increases, right? Okay, let's leave all this. Now let's come here. These are the basic things that we need to understand, right? So there is a two type of reflection, right? The first one is from this one and the next one is from this one. And one thing is also, let's assume we are in any, there is any sea or whatever you can say, right? If we are inside the water, like you are here, you are, we can say just inside the water. This is the water. So can we say inside water we are also able to see this level? Then what is happening? The light is coming to this one from us, like we can say there is a light is coming from this one to this one. Either if I am saying you are able to see this object, so it may be possible the light is coming to this one and this one. So what is happening? The light is incident on this water boundary and it reflects back. It means in this one there is also reflection. What is the difference between these two reflections? In this one, the light is reflecting from denser surface. This is the denser surface. And in this one, the light is reflecting from rarer surface, right? Because this is air, light is moving in this and it reflects. So it is reflecting from rarer surface. So we have two things: reflection of light from denser surface and reflection of light in rarer surface. There are two things in that, right? Just copy all these things, then I will move on to the next one. Okay, so let's move on to the next one. Let's see. So what I said to you, we have two things. One is, if we are saying there is a reflection, right? So there is a two type of reflection. Like I said, the one is from rarer surface, right? One is from rarer surface and another is from denser surface. There are two type of reflection we have. Okay, so what we have to remember in this one, like I said, this is a surface we have. We can say this is the mirror we have. You can say, I hope you know about mirror, right? This is the mirror and this one is what? Air. If this is air and this is mirror and the light is just incident on this one, so we already will reflect back, right? So this is traveling in air, no? So it incident from air and reflect from this surface. So mirror means what? Can we say this is the glass is here and this is what? Air. So reflection takes place from air or glass? Glass, right? Because this one is reflecting surface. So if reflection takes from denser surface, then there is a change in phase change, and there is a path change. Phase change and path change. I hope you know about this one from the wave in class 11th. What is the phase changes here? Phase change is pi. And what is the path change? It's a lambda by 2. What is the path change? Lambda by 2. Okay. So let's see here. If I am saying we have a error, like let's assume this is the water surface we have, right? If this is the water we have and we are saying the light is incident on this one. When the light is incident, so this is air and this is water. So it is reflecting in the same medium. So what is happening in this one? In this one the phase remains same. Phase and path. Phase and path difference will be zero. will be 0, right? In detail we will discuss in the wave optics, but if you want I can just give you some basic intro of this one. Let's see actually how the phase is changing and how the path is changing. There is a formula, phase difference and path difference, right? We all know about that one. The path difference is basically it's 2 pi by lambda into delta x. You all know about that one. But let's see here how we understand this one. If we are just coming on light now, so light is what? Light is a transverse wave. Light is what? Transverse wave. If light is a transverse wave, you know meaning of transverse wave. There is a perpendicular vibration. No? In light, electric field is vibrating like this. This is a perpendicular vibration and this is the wave is moving over here. What is the transverse wave? When the particles of the medium vibrating perpendicular to this one. So if I am saying light is a transverse wave, then let's see here what is happening with this one. We can, for understanding, we are just taking the string wave. What we are taking? A string wave, because a string wave is also transverse wave. So let's assume a string wave. This is also how the string wave is moving, you know, right? This is the string wave. So let's try to understand this reflection. Okay. So first I am taking, in the case of a string, this is the pole we have, right? It's a simple pole we have, and this is the string we have, and we have fixed at this point. At this point we have fixed this one, right? So if we have fixed the string and now we are plugging from this side, right? So when we plug from this side, then what will happen? The wave, the pulse start moving in this one, right? This is how the pulse is moving. So at this point, what is the meaning of the wave is traveling over here? If we are just concentrating with any particle, like this is the particle. So what is the wave nature is here? It will displace the particle up to a point, right? It will displace a particle up to a point A, it will displace a particle up to a point A. But wave is just incident on this one, so there is a support. It will reflect, right? So when it will reflect, so it's not possible that this point will comes down up to it, because this is a fixed point. But what is the nature of wave? It is trying to take this point at a displacement A in downward direction, but it's not practically possible. Then what will happen? Wave itself change its orientation. This is moving in downward. So what is when the wave is returning? So it will return like this. Now you can see what is happening in this one. This is a reflected wave. This one is a reflected wave, and this one is incident wave, right? So what is happening? This is the phase of all the particle when the wave is incident, and when the wave is reflected over here, this is the phase of all the particle. So they are opposite in phase. They are opposite in phase. Opposite phase means what? Pi. So that's why we said if there is a reflection from any denser surface, then what is the phase difference? Pi is here, right? So this is you can just correlate with the string wave, right? Now let's see the next one. The next one, if I am saying this is the string we have, and this is free end. This one is what? Free end. It's only I am just telling you basic of this one to understand these things, right? Otherwise there is a lot of concept in this one. So let's see here. If I am saying we are plugging from this side, then wave start traveling, right? If the wave starts traveling on this one, but this is free now, so it can be displaced. So when the wave will reflect over here, so it will reflect in the same orientation. It will reflect in the same orientation. When it will reflect in the same orientation, so there is no change. So that's why there is no change. So you can just correlate these two things with that one. The fixed will act as a denser and the free will act as a rarer surface, right? I hope you understand all these things. Okay. Now let's see some basic problem of this reflection. If I am saying, let's see the basic illustration. I am saying this is the reflecting surface we have. If this is the reflecting surface we have, and the light is incident at this point and reflected like this. This is the normal we have. This angle is I and this angle is what? R. So we are taking some data now. Let's see. If I am saying the I is 30 degree, so we all know what is the R is here. R is also 30 degree, right? And this angle is called angle Z, right? Angle Z means what? Angle Z is called grazing angle. This is what called grazing angle, right? Grazing angle. Either You can say it's a glancing angle. It's a glancing angle. Grazing angle, either what we can say glancing angle. If this one is the grazing angle, so what is the value of grazing angle in this one? The value of grazing angle in this one is what? 60 degree, right? Now let's see the next illustration. If I am saying, there is one term that also I am just discussing, let's see. If I say this is the surface we have now, a light is incident on this one. Now what will happen? It incident normally, so when we draw the normal over here, it will be on the same line. No? If it will be on the same line, I mean the normal is on the same line, so what will happen? It will reflect back on the same line, right? So this is normal incident. In the case of normal incident, what is the I? 0. What is the R? 0. What is the glancing angle in this one? 90 degree, right? So we will see in this one, this is a normal incident. This is called normal incidence, right? Okay. Now let's see the next. If I am saying this is the surfaces look like this, right? This is the surface over here. If this is the surface and light is incident on this one, like this is the light is incident on this one. Sorry. If I am saying the light is incident on this one, so we have to draw the normal on this one, right? So you know the angle is 90. If angle I is 90 degree, then what is the angle R is here? That will be also 90, right? If this is the 90 over here, then this is called grazing incident. This is called grazing incidence, right? This is called grazing incident. Okay. And what is the angle is here? 90 and 90. And in this one, the grazing angle is 0. Okay. Now let's see. If I am saying this is a surface we have now. This is a surface we have, and a light is incident on this one. Like the light is incident over here, and the angle is what? We can say 30 degree. So we have to find I and R. So first we have to draw the normal over here. So can we say this is the normal we have, right? If this is the normal over here, then this is 30, then this is also 30, right? And this one is what? 60. So what we know? The angle I is equals to 60 degree, as well as the angle R is equals to what? 60 degree. Why? Because what is the I? Angle between normal and incident, you know? That is called I. Now let's move on the next. If I am saying this is a surface one we have, this is the another surface we have, right? A light is incident on this one at an angle 30 degree, right? And again after reflection it incident on this one and it move like this. So what I am asking, angle of incident on both the surfaces. So what will happen? This is the normal and you know this is the normal. I hope you will do it, right? This is 30, then this is what? 60. This is what? 60. This is what? 30, right? If this one is 30, then this one is what? 30, 60, right? I hope you will do it. Now let's see some more problem on this. If I am saying this is a surface we have now, let's see here. This is x-axis and this is what? Y-axis. I will just a minute. I have to draw it like this. Let's see here. Okay, so this is a sphere we have, right? We can see it is given like this. This is x-axis and this is what? Y-axis. And what is the radius of this one? R. Now what I am saying over here, a light is incident on this one, right? A light is incident on this one. Like this one, light is incident over here. I hope it's straight. Okay, let's assume this is straight. If I am saying a light is incident on this sphere and after the reflection what happened? It becomes vertical, right? It becomes vertical. When it becomes vertical, then we have to find out the coordinate of this point. Can we find out the coordinate of this point? Let's see. This is what? The radius is R. If it becomes vertical, then what is the angle is here? 90 degree. And you know, this is the normal over here. And for any surface, the normal is passing through this one, I mean from center. Either we have a ring, either we have a sphere, right? So what we will say in this one, In this one we can say this is the 90 degree and this is R. So this is what? 45 degrees here, it's obvious. So this is what? R cos 45, and this one is what? R sin 45, right? So what is the coordinate is here? R cos 45 and R sin 45, right? This is the coordinate for this condition. Okay, either you know the 45, so it's a R by root 2 and R by root 2. This is the answer we have, right? Now let's see the next illustration. If I'm saying there is a, you can take any type of curve, whatever you want. Like let's see here. I'm just taking a curve over here. This is the curve we have, right? It looks like a parabola. So let's see. This is the curve we have. It's a reflecting. Right? This is X and this is what? Y. Now what I'm saying, the light is incident on this one. If the light is incident on this one, then we have to find out, if the light becomes vertical, then we have to find out the coordinate for this. And there are some conditions are given. What are the conditions over there? The conditions are given like, this is given X is equals to 2y square. So find out the coordinate of this one when the light becomes vertical. So you know, if the light becomes vertical, then what is the angle is here? Angle I is 45 and angle R is also 45. So first we need to draw the normal, right? But you know, in maths, if we have to draw the normal, then first we have to draw the tangent, right? If we will draw the tangent over here, then what will happen? If I am saying there is a tangent, let's see here, just a minute. If we have to draw the tangent over here, so can we say it will look like a tangent on this, right? If this is the tangent, then what is the angle is this one? This angle is 45 degree. It means, what is the slope of the curve at this point? 45, I mean tan 45. So what is the tan 45? The tan 45 is 1, right? So what we will do in this one, you know, slope of the curve, this is what? In this one, what is the slope? Slope is, in general, we are saying it's a dy by dx is here. This is y and this is x. So it's a dy by dx. If this is dy by dx, so let's differentiate it. What we can see over here, this is dx by dy. You can just differentiate like this also. This is what? 2, and what is the differentiation of y? It's a 2 into y over here, right? So what is the dy by dx? The dy by dx is 1 by 4y, right? And dy by dx is slope, no? So this is equals to what? 1. So what is the value of y? The y is equals to 1 by 4. This is value of y. If this is the value of y, then what is the value of x? X is equals to 2 into y square. Y is what? 1 by 4, so it will be 1 by 4 square, right? So what is the result is here? 16, 2. Can we say it's a 1 by 8? So what is the coordinate is here? The coordinate is 1 by 4, comma 1 by 8 is here, right? This is the answer we have. Okay. Now let's see one more illustration. If I am saying there is a curve is given like the y is equals to, we can say it's a 2l by pi sine pi x by l, and x is between 0 to l. Now what we have to find it out? It is the, I am just drawing the curve also. No? Let's see here. You know, it's a sine over here. So this is x-axis over here, and this is what? Y-axis over here. So how we will draw the curve over here? It's a function of time, right? So let's see. Is there any? No, right? Let's try to draw with this one. Sorry. Okay. So let's see. This is the curve of sine over here. Right? You know, there is a further curve is here, but we are not taking that. So this is given that, because we have to take only up to pi now, because when we will put the x equals to l, it will be pi. Now what is happening in this one? Light is incident over here now. Let's see. A light is incident on this one. This is how a light is incident over here. If a light is incident over here, so we are saying, let's assume this is the light is incident, and after incident it becomes vertical. It's the same type problem. After incident it becomes vertical. So we have to find this coordinate. What is this coordinate? How we will find it out? It's the same. What we have done in previously. We have to draw the normal. So this is the normal we have. What is the angle I? The angle I is equals to angle R, right? If angle I is equals to angle R, so what we will say in this one? First, if we have to draw the normal, then we have to draw the tangent. So can we say this is the tangent over here? What is the angle is here? You know it's the same. That is what? Tan theta is 1. Or you can say the theta is 45, whatever you want, right? Because if that one is 90 degree, so this angle is what? 45. If this is 45, then what is the slope at this point? 45 degree, right? So let's find out the slope of this one. What is the slope of this one? dy by dx. So let's differentiate this one. This is what? It's a 2l by pi into. What is the differentiation of sine? It's a cos. It's a cos, and this is what? Pi x by l into. What is the differentiation of angle? Pi x by l is what? Pi by l. Then what will happen over here? Let's see. Can we say the pi will be cancelled out with the pi, l will be cancelled out with that? Then what we have? We have dy by dx is equals to the, this is what? 2, and this is what? Cos pi x by l. And we know dy by dx is what? 1. Because you know tan theta. Tan theta is what? Dy by dx. So slope is 1. So let's put equals to 1. So what we will see over here? The cos pi x by l is equals to what? 1 by 2. We have a limited range, so what will be the value of 1 by 2? Actually there is a 2 value of 1 by 2. That is the first one we can say over here, and next one is over here. So let's see here. So what is the value of this pi x l by 2? Can we say it is the cos, either I am just writing it directly. Can we say it's the pi x by l? This is value of what? 60. 60 is what? We can say pi by 3. So pi will be cancelled out with the pi. X is what? X is L by 3 over here, right? So what is the value of x? L by 3. If x coordinate is L by 3, then what is the y coordinate? Let's put it here. The y is equals to 2L by 3 into, this is what? Sine pi by L into x is what? X is L by 3. So L will be cancelled out with the L, there is 3. So what is this one? Y is equals to 2L by 3 into, this is what? Sine pi by 3. What is the sine pi by 3? It's a root 3 by 2. So it's a 2L by 3 into, what is the sine pi by 3? It's a root 3 by 2 over here. So you can see it will be, where is the L? 2L, sorry, it's a 2L by pi, sorry. This is what? 2L by pi. This is 2L by pi over here. So 2 will be cancelled out with the 2. So what is the y is here? Y is the root 3L by pi. This is the value of y coordinate, right? And you know there is a 2 coordinate. If this is L by 3 and root 3L by 2. So can we say there is 2 coordinate? L by 3 is here and this is root 3. What is the height is here? The height is root 3L by pi. So can we say, let's draw a line over here. So there is a 2 coordinate over here. This one is the first one and this one is what? Second one, right? Because there are 2 values for same, right? So what is the coordinate of this one? The y coordinate is fixed, that is what? Root 3L by pi. But what is the x coordinate is here? The x coordinate is, what is the total length? The total length is L. So just subtract this one because it will be up to same length from here. No? The value will be same length. So total is L, so subtract this length. So what is this? L minus L by 3. So that is what? 2L by 3. So x coordinate is 2L by 3. Right? This is the another coordinate. So what they can give in the options, they can give us like the first coordinate is L by 3 comma root 3 L by pi, and the second coordinate is what? 2L by 3 comma root 3 L by pi. This is the answer for us, right? Okay. Okay, so we have done the basic things related to the reflection. In the next lecture, we will start the angular deviation, right? Or simply we can say deviation. Deviation is angular deviation, right? So we will start the angular deviation in the next lecture, right? Okay, bye-bye. Thank you.